Okay, let's work this last page of short problems slash multiple choice concept questions, all as one part here. So first one, determine the dot product of 2i plus 3j newtons, dot product with 4i minus 5j meters. So recall that the dot product was simply the product of the x components. So it's 2 newtons times 4 meters. Okay, and that's a scalar value. And it's going to be added to 3 newtons times minus 5 meters. Alright, so 8 plus a negative 15 is going to be a minus 7 Newton meters. Okay. One real common mistake is to think that this still has an I and a J. Those are scalar values, so they can just be added up. Okay, Newton meter could also be written as joule. Either one is fine. Alright, Chris climbs a 40-foot high staircase in 12 seconds. Jeff weighs 1.7 times as much as Chris. How fast would Jeff have to climb the stairs to exert the same amount of power? Alright, so what we're looking for here is just to see that you know the definition of power is work over time, and they're exerting the same amount of power. So the work by Chris over the time of Chris is going to be the work of Jeff over the time of Jeff. Okay. The work done by Chris is his weight. Okay, because he's going up the staircase, so he's going against gravity, times the distance. So we're going to write this, let's see, this W is work. So the work done by Chris is the weight of Chris. I'm trying to figure out how to write weight here. I'll just call it the force of Chris times the distance. So the force of Chris we'll just call F sub C times 40 over 12 seconds. And we're going to have a similar thing for Jeff here. Jeff weighs 1.7. I've run out of room. I'm sorry. Let's move all this over. Come on. If it'll cooperate. Here we go. Alright, so Jeff weighs 1.7 times as much. So that's what we're trying to get you to do, is put that relationship on. They're running up the same stairs, so the distance is the same, and this is the time for Jeff. So it boils down to the time for Jeff is just this ratio here. Okay, so the 40s cancel out and the FCs cancel out. So the time for Jeff looks like it's going to be 12 times 1.7. Doesn't have to run as fast because he's bigger. So that's equal 12 times 1.7, and that number comes out to be 20.5 seconds. 20.5 seconds. You didn't have to show this much work on this problem. I was just trying to do that to explain it as part of our video here. Alright, so 2-point multiple choice problems. The figures show 2 frictionless ramps. The heights y1 and y2 are the same in each picture. Alright, so their starting and ending positions are at the same height. If both blocks have the same mass and are released from rest, which block has the greater speed at the end of the ramp? Okay, we're going to neglect air resistance. It's frictionless, so the initial potential energy is going to be converted to final kinetic energy, and it's going to be the same for both. Okay, because they have the same change in height. That's all we're looking for on that one. Golfer making a putt gives a ball an initial velocity of v, but he badly misjudged it. The ball only travels 1/4 the distance. If the resistance force due to the grass is constant, what speed should he have given the ball in order to make it to the hole? So what we're looking for here is you've got some sort of initial velocity, and that's going to translate into some energy loss, force times distance, in order to get the ball to go this distance. So we're assuming the ball basically will be going stopped or very close to stopped when it gets to the hole. Okay, so we'll have this relationship right here. So kinetic energy is 1/2 mv squared. It's equal force times distance. Okay. Looking at this, if we go, what's the problem say? It goes 1/4 the distance. Alright, so we need to travel 4 times as far. So I'll write that, need to go 4x as far. Just thinking about it in words. What speed do we have to do that? So if we want to increase this by a factor of 4, f is constant, what are we going to have to do to v? Well, v is squared here. So you only have to do 2 times v to go 4 times as far, because the 2 is getting squared. Okay. You could write it out, but I think just talking through it is sufficient. You drop a ball from your hand, it collides with the floor and bounces back up half as high. The collision between the ball and the floor is an example of what? Okay, half as high, so energy loss. It's not perfectly inelastic, because that would be sticks. Okay, it's not an explosion because they're not stuck together at the beginning. It's not perfectly elastic because that one has no energy loss, so it has to be what we call an inelastic collision. Okay, and our last one here, 14-pound bowling balls going down the alley at 27 feet per second, directly strikes 3.5-pound pin. Speed of the bowling ball relative to the pin after the collision, perfectly elastic. Alright, so we want the velocity of the ball with respect to the pin after the collision. Okay, and if you remember our equation for perfectly elastic, that's equal to the negative of the velocity of the ball with respect to the pin before the collision. Alright, so there's 27. It's going to be the minus 27 answer. Okay, this problem was misworded a little bit poorly. That one should have said velocity. Okay, and because we didn't word it correctly, we also accepted the plus 27 answer. But we intended to ask velocity to factor in our negative number here. Okay, that's it.